Here are 10 more of our favorite videos. I thought this video might be helpful for those who are trying to understand how a hip roof is constructed. I won't be providing you with all of the details on how to build it, but give you an idea of how it's actually designed. So you can see the roof sheathing here. We use 4x8 sheets, and then the corners will need to be mitered, and in some cases you're going to need to, you won't be able to cut them flat. The steeper the pitch, you might actually need to cut some type of an angle on the plywood. For example, you have a square cut on this side, square cut on this side, and on this side, but this one might actually need to be angled a few degrees to make it work. And I noticed that with the steeper pitches for sure. So this is a hip roof with roof sheathing. Here's what it would look like without the sheathing. And of course the star of the show is the hip, and the hip is usually going to be a larger board. If you have 2x10 rafters, you might have a 2x12 or even a 6x14. I remember one job we did, I think it had about 32-foot glue lam. It was a large hip. I didn't like the way the bottom connected on the job we did, but that's another story. The blocks are usually going to be angled here, and angled, you'll have an angle coming down, and then of course it will be mitered. The rafters, not uncommon to have rafters. We used to refer to these as flyers, and you got to keep going 2 foot on center. You don't want to leave these out here. Let's take a look at the hip, the base of the hip. It's usually going to be a little longer. Zoom in here. This is going to be a little longer than the common rafter or the jack rafter seat cut also. Go up to the top. The hips usually connect to common rafters. You have your roof ridge. And then actually this is a common rafter, this is a common rafter, and this is the same rafter, believe it or not. This is actually how you can find the point here, is with the common rafter. And maybe I'll do a video on that later, how to actually build this thing. So hip, common rafter. Let me do that again. Common rafter, hip, common rafter, hip, jack rafter, common rafter again, and the roof ridge. Another view of it there. The jack rafter again is going to be mitered, and this is usually the same cut as the pitch. If we have a 6 and 12, this would actually be a 6 and 12 cut with a 45-degree angle. There's what the seat cut looks like again, fascia. Zoom out here, another view of it. Let's talk about the ceiling joist. The ceiling joists here are 16 inches on center. The rafters are spaced 2 foot on center. Every 4 foot, we are going to need to connect this, the ceiling joist, make a connection with the other side. So 4 foot, let's just pretend like this is 0 inches, and then 16 inches, 2 foot, 32 inches, and then 48 inches. So 4 foot would be every other rafter on 2 foot on center, and every third rafter 16 inches on center. And again, these need to connect. These are basically holding the building together. They will need to lap at the, they don't have to. This is just one way of doing it. I like doing it like this. Gives it a nice solid connection, a nice tie across. And then let's look at the other side. Now the one thing is, you do the math on this, these rafters are not going to line up. You're going to have to put some type of a spacer block, whether it's at the rafter and the ceiling joist at one end, as I have it drawn here, or in the center where the wall laps. Either way, in order to have this work out and have your rafters line up. Now you can do this, you can move the ceiling joist and then move the rafters over, but then you have a problem tying the rafters together at the top with collar ties and or straps, whatever you need. So this right here is just kind of another way to do it, a block here and a block here. Back over to here, it's not going to be uncommon to have regular ceiling joists. I believe these are 2x8s. And I think you can see here where it drops down a little bit. As you get closer to the hip, or you get closer to the wall on this side, you might need to make smaller joist. You might even need to, be able to, or just only be able to get away with using 2x4s in some cases. So keep that in mind when you're building. Usually this is how we finish the corners, with some flat blocks. Let them overhang about 1.5 inches, and then that'll be for your drywall backing. And they simply nail on top of the wall framing plate. I wanted to give you one last final look at the roof without the walls and the ceiling joist, give you an idea of how it gets put together. Common roof rafters here, roof ridge here. Our hips are right here. Hips, we have 4 hips, 4 corners, 1 for each corner. And then our fill rafters, or our jack rafters, over here, with another common rafter in the center. And of course our blocks. Closer view of it. Another view. It's nice to have your jack rafters all line up too, and it's easier to cut them because they're all going to be the same size. So if everything works out and your roof looks like this, you'll have done a pretty good job. Another view of it there, the hip. Remember, sometimes I said the hips are going to, and I'm seeing a lot of that nowadays. The older homes that we used to work on when I first got started would have a single hip. Be like a 2x10 if these were 2x8s, and that was fine, but they sag and too much weight. If you can brace them, fine, but you'll see, even if you look at this house here, that there are a couple of walls where you could actually put a brace underneath the hip to a wall, but I believe over here there might even be a garage. You're not going to be able to do that. On the other side, I think, is a large room, so not always going to work out. That's why they require larger materials for the hip. So that is it for the video. In this video, I will try to provide you with at least one way that you can frame a hip roof home edition off of an existing building with a hip roof. So again, the main thing is going to be the roof framing, not the doors, the windows, or the foundation. Let's remove the plywood roof sheathing, the blocks, and frame some walls here. Zoom in on the rafters. Now I removed the blocks. We have a block here. They were removed. And this all depends. You might need to remove the eave blocks. These would be painted. You'd be able to see them from underneath. Or if you have a soffit, you might not need to remove some of this stuff. But if you're going to frame it the way I'm going to do it in this example, you might have to remove these blocks here that were over here, and then even reblock it. But that all depends on how it's actually framed. So rafters here will need to be cut. So let's get to it. Here's what it would look like with the blocks and the fascia board. Make sure that you leave as much of the fascia board as you can until you have the roof framed, to see if there's actually a rafter that's going to line up. Now I'm showing you this without the roof sheeting, and this is just to provide you with an idea of what we're doing, but you're actually just going to remove some of the sheathing to where you can install the blocks, and you might need to snap a line across here, cut the plywood, and then slip the blocks under here and nail them in. Obviously the way I have it here looks easier, but this might not be the situation you're going to be dealing with. You can cut the hip. You can do this basically 2 ways. You can have the hip continue down and leave your filler rafters in here, or your flyers. But for this, I think, it looks a lot nicer if you can have everything look uniform, and that's how it'll be when we're done with our example. So again, the fascia board, let it extend past. Another view there. And here's what it would look like from the top. Home addition, walls, existing building, and existing roof. Here's where the magic begins, and hopefully you can see how the home addition roof is going to work. Here's the roof sheathing that would be cut over the blocks, and you actually need to nail the sheathing if it isn't already nailed. Well, I guess it wouldn't be nailed. Would only be nailed if you had existing blocks in here. And if it was actually nailed too. It's not uncommon. So here we have our roof ridge sitting on top of the existing sheathing, and our two hips, fascia board, and you can see it here lining up with the rafter that we used. The hip right here, blocks, and our little flyers, and then our fill rafters or our jack rafters. Now here's what I was talking about. You might have a rafter that blends in here, and if that's the case, you know, if it's over a little farther, over this way farther, if you were to just cut your fascia board before, you might be replacing it back to here. So, and I'll leave that up to you. This is just kind of a pointer, something I used to do when I would do room additions. I would just leave the fascia board alone there and cut it when I was ready to install the fascia board. Another view of the roof. Ridge sitting on top of the sheathing. Ridge connecting to the hips and the common rafters. Another view of the fascia board and the new blocks that would be installed for your room addition. So this gives you an idea how you would frame this. Let's take a look at how you would frame the fill, and I'm going to put a link at the end of the video here for another video that I did on how to actually cut and install these rafters. Just a little more information on it. Not going to go over that in the video. This video is just to give you an idea of how the framing would work for something like this. So here we would have a backing board, and this one here would die into the common rafter or one of the fill rafters. I know that everybody thinks, hey, let's just run it out to the edge here. That will not work at all, so don't do it. Okay, the ridge. Now the ridge can sit on top of these backing boards, or it can sit on top of the sheathing. I like to use it on top of the sheathing because that way I can use the ridge to get the measurement for this board here. Makes it a lot easier. Another view of it there. And if I was to remove the sheathing, I should be able to put a straight edge across here and have it all blend in. All of this should be straight to the rafters. Do not build this to the sheathing. That won't work. So this has to work with the rafters, the existing rafters. And you might need to remove some plywood if that's the case to get everything to blend in. And that's it. That's the hip roof. For this would be kind of like a roof plan here. A few more things that I thought I would mention. When you install a roof over an existing roof, you need to have some type of ventilation holes. This allows air to travel through the framing, and you won't need these if you have enough ventilation in here, but I like to have the cross ventilation in here. And sometimes you're allowed to cut a 15-inch by 15-inch hole. You would probably need to contact your engineer for more information to find out what the maximum size or how many you could put in there. And this is important. It's nice to be able to use support boards to take some weight off of the roof here, and especially for the ridge, if you can get as close to here as you can to where the hips and everything connect. And this here that I have, it's running vertical up and down. You could actually move it over at an angle, but I think this right here would work for the best. And here I'm using 2x6, 2x6 under the ridge, and then 2x6, one on each side. This creates a nice sturdy, kind of like a post. When you nail this together pretty good, you've actually got a post. You just put one board here. You're probably going to need to actually put a brace run a brace off to keep this thing from moving. So this right here would work pretty good. And then you can set it on top of a block. This block could run this way or this way. Or you could remove the sheathing and run these all the way down to the existing, to the top plate of the existing wall there. Now let's talk about the sheathing. The sheathing can be installed a couple of different ways. I have it on the other side where we actually removed the plywood, but if you're not going to remove the plywood, you can actually do something like this. And you can see here that the plywood or the roof sheathing is blending in. Top of the roof sheathing here is perfectly, planes in perfectly to the other roof. Again, this position of this is critical. Make sure that it's not sticking up and creating a problem where you get a hump in the roof. And even if you have a little hump, you know, if you put a straight edge across here and it's off maybe a ½ inch, you're probably never going to see that. Even an inch you might not ever see after it's roofed, depending upon what type of roofing materials. If you're going to use tile, you'll probably never see it. Composition shingles, you might see it. But this, again, the plywood here, you know, I'll leave it up to you if you want to miter it. This is a straight cut here. Zoom in on it, and there is going to be a little gap here. If you just come down here at a 90-degree angle and cut it, so that could kind of look a little confusing if you're looking at the picture here, but won't look that way after when you're building it. So here we can see a nice line, nice and straight. I always like to see straight lines in whenever we're framing something. So here's one way, and I did this like this. You could actually take this piece of plywood or roof sheathing and run it over to here and just cut a section like this and then run this one all the way over. Have this over to here where you wouldn't need to install little filler pieces. So something else to think about. And this side over here actually just removed the plywood. But again, this is something you might not want to do. It's going to cost you a little more money, but your engineer will love it. He'd love to see something like this, a nice solid tie running through here. And you could get that with these. That's definitely, this right here, in my opinion, would be better than the other one. And who knows, you might actually need to install blocks with straps in here to get a connection where your roof sheathing, doing it like this would actually work probably better, in my opinion, than it would be if you strapped everything together. So anyway, that's it for this video. And if you are building a room addition with a hip roof, keep this one here in mind. This is actually something you could use as a model for your construction. But like always, I have to say, you know, this might not work in your area. Always, if you're going to get a home addition, do a room addition, always good to contact an engineer to get all of the lumber sizes and get everything calced out so that your building doesn't start sagging or fall down in the future. In this video, I will provide you with a few different methods that you can use to connect a home addition to the roof sheathing and, of course, the framing. If you are going to tie two walls together like this, you're going to have an existing framing plates, existing structure, and then you're going to have new framing plates. They're going to usually need to be tied together with a strap, and this strap is usually going to need to be 48 inches long. It is a long strap and requires a lot of nails. So that is about it for this. And don't forget, these are just examples. Your engineer calls out for something, you will need to follow their rules and get rid of mine. So straps, usually 24 inches to 32 inches on center, spaced apart there. And they nail into the top of the plywood. And if you do not have a block underneath it, one will need to be installed. So whether or not you install the blocks flat or on edge will be up to you, depending upon the length of the nails. Keep in mind that these straps are basically attaching the roof sheathing together, not the framing. You could see here that if you were to nail an end nail or toenail this block into the rafter with enough pressure, it could actually separate. Same thing over here. So keep in mind the straps are tying the sheathing together. Just using the blocks for a little additional support there. That's what it would look like. Let's go ahead and take a look at method number 2. Method number 2 might require you to remove a section of the sheathing, the existing sheathing, so you can get, instead of a 4-foot, you might get an 8-foot board in there long, but this would require you to remove more of the roofing material, so it might not be the best bet unless, of course, you're planning on re-roofing the entire house. And something like this would be great. Or it could be used in with a combination of this and that. You could always use the straps and this method. So you would remove the smaller piece of plywood and install a full sheet there. This would tie the two structures together and be a nice tie, because this was the same method used as you're using over here. And then sheet the entire roof and you are done. So like I said, you could always combine this method and this method for extra sturdy strength to make your engineer even happier. So here's another question I received. The individual wanted to know if I had any ideas on how they could build a fence on top of a sewer pipe. And I actually have this situation at my house. It's not a sewer pipe, but it's a street drainage pipe. The street above, let's say in the backyard of my house, actually drains down to our street and then drains down to the next street. And it runs right down the center of the property line. So good job with that one. Could have moved it over a little bit. But you could actually do something like this. Go a couple of panels, maybe 16 feet, come in, whatever the desired distance is. If it's a sewer pipe, you might only have to go a foot, something like that. Might have to go 2 foot or 3 feet if it's a city drainage pipe. And again, I'm just going to try and provide you with a few ideas here. This is what it would be looking at it from above. The pipe would go down here, and hopefully the footings would not be next to it or on top of it. And when I say next to it, I would imagine you got to keep these footings at least 4 inches away from the pipes, and try to keep them to where the footings are going down. And there are certain rules of thumb that you need to follow for pouring footings. If you get into those, I really don't want to get into that. This is a fence. This is not a structural home, a room addition, a building foundation, kind of like that. It's a fence, not going to be a lot of weight. So you probably could actually pour the concrete within an inch of the pipe and be okay. Here's what I have on my property. The fence jogs a couple of panels and then jogs over and then goes all the way down on the neighbor's side. And it's kind of hard to tell who got the better end of the deal there, but that's how the fence was built. I would be thinking that you could actually go a couple of panels, just like with the 90-degree angle. You could go a 45-degree angle if you wanted, go a couple of more panels, and then go back 45 degrees and then work your way down. So you'd actually have 2 panels, 45 degrees coming in this way, 2 panels, and then go 45 degrees that way, go another 2 panels, and then come back in and stagger your way down the property. And again, this is just another idea. You might want a 45 one panel and then 90 degree another angle. I don't know, that will be up to you. If you do want to build the fence over the pipe, then you could always use some type of a bracket system like this. And if you do use a bracket system like this, wouldn't be a bad idea to alternate your footings, put them on either side of the pipe. If you are going to do something like this, this will have a footing on the right side, this one will have a footing on the left side, and they will bolt, everything will bolt together and then bolt to the wood post. And of course you could always use a metal post here bolt the angle iron to the metal post, or somehow come up with a design to where you bolt the angle iron to a round fence post if that's what you are going to use. Again, these are suggestions that you might need to use a few of them to come up with the best design you're looking for. This is kind of an idea of what the footing could look like. Again, alternating. You can see one on one side, one on the other side. The bracket, the post, or the angle iron coming up out of the concrete. Now this actually, I have the fence post going into the concrete. If you want, you can stop your fence post above the concrete, but I think if we go down into the concrete, it's going to give us a little more stability. If this ever rots and you do need to replace the fence post, then you could simply chisel out this stuff, get a vacuum cleaner, pull all of the wood out of it, and then reset the post in there. If it does rot and you see it rotting and it looks like a problem, you could always cut it after that. Cut it after the fact, maybe a 1/4 inch above the concrete. And if the fence is still sturdy through the metal support system and the concrete foundation, then you're fine. But again, I would go ahead and put the post into the concrete. I think it's going to provide you with a little more stability. I mean, if you're only talking 3 or 4 inches, why bother? Pull the post up. But if you can get at least 6 inches into the concrete footing, then that's probably going to help a lot. So, and again, alter the footings back and forth. Close up there. And then gives you an idea of how this is going out here. Let's go back to this close-up again. You could actually pour the concrete up above the soil, have it around the wood post like you would a regular wood post that would be going into the ground. But again, I don't want to raise this concrete up. That'd be too much sticking out. So you could always just make a smaller section. If you have a 4x4 post, maybe something that's 6x6, bring it up above the ground, and that's probably going to provide you with a pretty good foundation. In the last section of the video here, I just kind of want to throw out a few different bracket design ideas. This is the original bracket that we had in the video. This one here might work, especially if you're dealing with a smaller fence. If you have a 3-foot fence, this might work. And of course, you would need a welder. You know, you'd weld something like this to create a nice, strong bracket. You could always use a design like this, weld it together, and then weld a couple of flat pieces of metal on the side to make it even stronger. The footing would look something like this, concrete footing, flat. You know, you could always go down and then go around the pipe with a bigger footing, use some rebar, bend the rebar to go in there, and create a stronger footing and a stronger support system. You could always change the angle of the bracket. Any brackets in here, you know, if you don't have the room, you might have this bracket going straight up. This bracket here might be at an angle. You know, you could run this at maybe a 20-degree angle, and then of course change the angles of anything to make the bracket work. You know, I'm going directly over the post. If you're to move this to either side, you're going to have more options available. You could always add another leg coming down, and again, this is going to provide you with more support. You know, anytime you have brackets like this, if I have this connecting to this, not going to be very strong. Once I add this section here, it's going to be a lot stronger. And then when I bring this over to here, I've really got a nice system here, really going in for some strength there. So, and again, you can always put a leg on the other side also with a bracket. This might be exactly what you're looking for. It just depends upon how much strength you need. So anyway, I hope that this provides you with a few ideas. Get a little creative. If you want, feel free to send me some pictures of what you have. I can put them on the website and create a website page and make other people aware of your design, especially if it is better than my designs. Here's another question that was sent to me. The individual wanted to know what in the heck you do when you're going to build a stairway. in a garage that has a sloping floor, and keep in mind that most garage floors slope from the back of the garage to the front, anywhere between a 1/16 of an inch per foot to a 1/4 of an inch per foot, and an 1/8 of an inch might be a little more common. Garage floors usually don't get a lot of water. It's not something that needs a big slope, but it all depends on the installer of the floor. So here's a stairway going up to a floor. I used to do a lot of these for condominiums, I remember. Now I think the easiest way would simply be to shape the bottom piece of treated lumber that's going to attach to the concrete. And you can do that by simply leveling across. I'll go over that in another part of the video. You would end up with something like this after it was cut. And then your riser would need to be cut also. You would end up with something like this. You might actually have to notch the riser over the curb that sticks out from the wall. Had to do that plenty of times. And this is kind of what you would end up with. Maybe you would have 1.5 inch 2x4 treated here, and it would slope down to maybe 1 inch or something like that, 3/4 of an inch, 7/8 of an inch. Rip that. And then I would install the treated part from the factory down, and then have the part that you cut sticking up so that you get more of the treated lumber in contact with the concrete. Look at the stairway there. The wall, that if you are going to have a wall that supports the landing, it will need to be a little shorter. If you measure and you have a 1 inch spot after you level it, then you will need to remove a 1/2 inch. Whatever you remove from the front, whatever you remove from this part here will need to be removed from the wall. Now you won't need to rip the treated lumber down for this. Simply remove whatever it is. If this is a 1/2 of an inch you're removing from the treated lumber, simply remove a 1/2 inch from the wall. If this wall right here, the wall studs are 20 inches, then the wall studs in the back would be 19.5 inches. And I just kind of wanted to show you, sometimes you can extend the risers past and you'll be fine with that. Might need to leave some room for some drywall to slide in between there. And you might actually need to install another stringer here also. Here's an example of what it would look like if you did not rip the treated lumber down. You would just lay a 2x4 on top, and these stringers are level. So this kind of gives you an idea of what you're dealing with when the concrete is sloping this way. This is what it would look like after you cut cut the bottoms off the stringers. This method here would be using full 2x4s. If you're going to use 2x4s, simply cut the stringers the desired height, and you could simply do that by leveling across. You would simply install this stringer here. I think I have it over here. Install the stringer here, put a level across, and then simply measure the distance to where the stringer is located. And you probably need to mark the treated lumber here so you can get an accurate measurement here also. Give you an idea. And this method here would be using a stringer from the side, but you could always use one from the middle. And this is probably going to be more preferred. You know, if you have a 7-inch rise, I like to see the 7-inch rise in the center. This is where most people are going to be traveling. You know, wouldn't be uncommon for something like this to have a handrail on it. People are going to be coming around here, and this would probably be the first spot they would step right here. You could actually move it over to here if you wanted to, but I think you're going to be okay if you have the if you have 7-inch risers everywhere else. Have a 7-inch rise here, and then this over here might be 7 1/4. This one over here might be I'm sorry, 7 1/4. This over here would be 6 3/4. Now you could always, if you're going to mark the treated, simply lay a piece of treated down there, put a level across there. But I think you would be okay if you just level across and measure it. Not too difficult, but I wanted to give you an idea, something of what you're looking at. For those of you who might not be familiar with the process, you could simply put a level across here and reach under here with a pencil and mark it, but I think you're going to be better off just measuring down. And give you another perspective there. I think this method will work best for figuring the total overall rise, to figure the individual risers, and that would be to simply go from the center, level out from the floor, whatever the overall height is, whether it's going to be a platform or the home, the floor on the interior of the house. Level across at the center, and then you could always level down here if you can't find the center, or put a 2x4 up here, and again, you might not need the treated down here for that. You could simply put a 2x4, just hold it with one hand while you're using the level, and mark the 2x4, and then simply measure the 2x4, and that would be it. So instead of having this right here, you would just have a 2x4 here, and then use the level to position yourself. It's not too complicated, but can be depending on what you're measuring. Hold the level up and the 2x4, and once the level is where you want it and looks good, simply reach under the level here and mark the 2x4. Measure the 2x4, and that will be your total overall rise. Now, if you're going to put it on top of the treated lumber that's not ripped yet, or if it is ripped, make sure that you have the 2x4 sitting on top of the concrete, not on top of the 2x4 treated. That way you get the correct total rise. So anyway, that's it for the video. Not too complicated. Sloping surfaces. I think the building code requires 1 unit per 12 units. So that would be 1 inch per 12 inches maximum. These garages here shouldn't be too big of a deal. They're usually, like I said, 3/8 to a 1/2 inch, maybe, depending upon how wide the stairway. If you're going to put a 6-foot wide stairway in here, you could be looking at starting from the middle here and having a 1/2 inch larger rise here and a 1/2 inch smaller rise here. But either way, I think going from the center is going to be the best option for. Here's an idea that might be helpful for anyone who is trying to repair the damage done to the bottom of an exterior stair stringer and needs to lift it. You can simply do it with a jack and a 2x4 with an angle cut on the bottom. Attach the 2x4 to the bottom of the stringer with screws. How many screws? I'll leave that up to you. I would imagine 1 every foot kind of would do. A 3-foot board might do just fine. On a heavier stairway, something like with 6x12 stringers, you might actually need to use an 8-foot or a longer 10-foot 2x4 and put screws every 6 inches in it, but I'll leave that up to you. Lighter stairways, maybe a 3-foot board with only 3 screws in would be perfectly fine. And then cut an angle on it. The angle doesn't have to be perfect. It, let's face it, we might not have a saw that cuts a 60-degree angle. If you do, great. If you don't, I think even a 45-degree angle would be fine. Center the jack on the pivot point here and raise it. And if you see anything where there's a problem, simply lower it, and you might need to reshape the angle here to get it to work. You can always put multiple boards on too if you want more surface area on the top of the jack here. You could screw another board to this one here, and that might give you a little more area. But I think something like this would work. Just make sure that if you're using a hydraulic jack, they can actually leak and lower. Keep your fingers, everything away from the bottom of the stringer. That is a definite. If you make a cut
You know, try and have everything ready to where you can make the repair as fast as you can, or use a screw jack. Screw jacks are usually pretty good. They're not going to leak, and they stay in one spot and seem to work pretty good. Another thing you can do, if you don't need to raise it, you just need to support it while you're making the repair, would be to simply build something underneath it to support it while you do make the repair. And something like this might work just fine on stringers that cannot be raised. And this might be a stair stringer that is attached to a wall somehow, and you're not going to be able to raise it. Simply put a support underneath it, cut out the rotted stuff, make your repair, and you should be good to go. So anyway, hope this video helps, and don't forget to check out our books on stair building at our website. And if you're looking for more information and a little more easier to follow step-by-step details, those books actually have helped a lot of people build their stairs, and might work out just fine for you also. In this video, I am going to talk about architectural planters and the possibility of keeping the soil level as low as possible to reduce damage. And hopefully you'll understand more about that by the end of the video. So here we have a planter wall. The soil level is low, but we still have the damage here. Keep in mind that the soil gets wet and absorbs into porous materials. Porous materials are artificial rock, anything made out of a cement-based product kind of a thing. Cement, sand, mortar, the mortar that's in between the rocks, brick, block, and of course stucco. Here we have a cement wall, or this would be a monolithic poured solid concrete structure with moisture absorbing out of the soil into it and creating problems for the paint. And you can actually see this is either a crack or an area where it's been repaired. Not uncommon to see someone come in and repair something like this, and then within a few years you end up with the same problem, because they're not doing anything about keeping the moisture out of the soil, or they cannot do anything about keeping the moisture out of the soil. Keep in mind also that concrete with metal in it rusts. This would include all of the rebar. If you have a raised level, and again, if this same effect here could be obtained by lowering the soil or redirecting some of the runoff, then the more water you can keep away from these structures, the better off you're going to be. And that's kind of what I'm trying to hammer home here in this video. Here's a soil level that's a little lower, and you've got the same effect here. The plants grow out of the ground and they're going to grow up. So if this soil level was 2 foot lower, you could actually have the same effect here with this plant, as if it would be if it was almost to the top of the planter here. Smaller planter here with a hedge, and again the soil level is low. If the soil level would have been raised, you could actually have the same problem. I'm guessing this is colored concrete here. This is not painted, but it doesn't mean you can't end up, if you raise the soil level, you can end up with problems in the concrete. Water over time can create problems for concrete structures. Here's something that has a lot of water in it, and looks like they use some type of bricks or blocks, and you can see where the water's coming through. Over time, this is going to weaken the structure, or it could actually come apart. So the concrete or the mortar that's in between the blocks could, or I should say, will weaken before the blocks actually come apart. But I've seen water, like I said, cannot say this enough, I've seen water practically disintegrate products made out of cement and sand. Blocks, not a brick really, but the blocks or the mortar just tears the mortar up. So this would be another thought you're going to need to keep in mind, is what products you're actually going to use when you do build your planter. Is it going to be a 4-inch block or an 8-inch block? Is it going to be solid concrete or brick, but you're going to need to take some consideration into that. The materials and the use of them, the planter over time, definitely need to be considered. Here's 2 concrete planters. One of them is goes all the way into the ground. One of them has a concrete floor. This one here is also up against the building. This one is away from the building. This would be the ideal situation. This one right here, the only thing you're going to have to worry about is the concrete disintegrating over time, or the mortar or the blocks, whatever it is. Over here, you're going to need to worry about the moisture from the ground that gets absorbed into the concrete footing, and then of course into the wood framing. Now, if it is waterproofed, and I know a lot of people, hey, why not just waterproof it? That's fine, great. Keep in mind, my job was to go fix all of this stuff when it was damaged. I got to see all this stuff firsthand. People waterproofing, hey, this waterproofing material has a 100-year warranty, and then the company goes out of business. I've seen this too many times. All you need is a small hole over here. And this small hole can allow water or moisture to seep into the concrete. It can pull it into the foundation, and it's not going to do you any good. So, and again, the reason why I'm making the video is to just maybe suggest lowering the level of the soil or the fill material so that you can reduce the amount of moisture, if anything, if you really want the planters. You're going to need a drain hole if you have a concrete floor or something that is water isn't going to seep through as easy. You do not want it to pool up in there, because that's going to create even more problems and allow more moisture faster to go into the concrete. So drainage is essential on anything that you seal with concrete or other materials on the bottom. Something else you could do would be to provide some additional materials to create some additional mass, let's say, to make the moisture a little tougher to get through. If you had a 12-inch thick concrete wall here, you're probably never going to have any problem with the foundation here. Take a lot of moisture to absorb through this to get to this. So just kind of thought I would throw that out there. Some additional mass might provide you with another idea. But don't waterproof both sides. Don't waterproof the wall up against the foundation and the planter, because this would allow moisture to get trapped in between the waterproofed areas. So that wouldn't be a good thing. Another thing you can do is keep the planter away from the foundation, maybe an inch away, but I don't know how far away you can go. You wouldn't want to have it, let's say, between 3 inches and 6 inches, because you could have they have problems with babies or young children getting their heads stuck in these areas. They're building code issues. So I would say if you're going to move it away, maybe 1 inch to 2 inches, or go maybe 8 inches to or further, kind of a thing. But keep in mind that these areas might need to be cleaned out, and 1 inch or 2 inches might not provide you with that. If you do put if you do end up with a 2-inch spot, make sure you have some type of maybe a vacuum or something with a hose that you can get in there and clean that stuff out whenever the debris builds up. You don't want the debris to build up, because once you have debris in here, now you have an avenue for the moisture to absorb through the planter into the concrete foundation. Here's a good idea what I'm talking about. Higher soil level, might raise this particular plant up a little bit, but why not put a lower soil level and then let the plant grow up to that same height, and reduce the amount of moisture that can get absorbed into the foundation. Again, I've said that enough in this video. I know it, but this is a big problem. People want planters. They want to fill them up with soil, and this stuff absorbs into the foundations a little faster. So lower them if you can, and lower them as much as you possibly can. I mean, if you can plant this on at ground level, you are going to be doing a lot better. So but again, you can fill them up with a little bit.
This could actually be a safety hazard. You might need to put some type of a barrier in there. If an animal or someone falls into there, they might not be able to get out. That could be a problem we don't want. You know, you come to clean your planter up one day and you see the skeleton of an animal in there. That might not be good. So a barrier like this might work. Another thing would be to put a concrete floor in it and just put some potted plants on top of it. Of course, this would need a drainage system, some type of a drain in the floor. But this right here would reduce your chances of problems drastically. So if you are going to use architectural planters, make sure you give some of the suggestions in here that I provided you with some thought. Lower the soil level if possible, use barriers, potted plants, and of course, don't get sold on a waterproofing system that will never fail. I have never came across that. And if you really believe that there is a waterproofing system that won't fail, then I got some swampland in Arizona I think you might be interested in also. So I made a video quite some time ago about prefabricated stair stringers. These would be stringers that are already cut to a specific size, and you can purchase them at your local lumber yards or home improvement centers. And someone wanted a little more information on it, and I thought, okay, I'll make another video. Always got time to make another video. Hopefully I will get it down to where maybe 90% of the people understand it this time. Prefabricated stringers usually have fixed risers. So let's say it comes with a 7-inch riser and a 10-inch tread, but you need a 6.5-inch riser and a 11-inch tread, or you need a 5-inch riser. These won't work. Prefabricated stair stringers are kind of a waste of time, and I'm going to put a link in here to where you can check out one of my books. And of course I'm selling my book. Why wouldn't I be in this video? And I'll put it up here so that you can go check it out, some of our stair building books. I recommend cutting your own stair stringers unless you're going to purchase the prefabricated stair stringer and then build your deck or platform to that particular stair stringer, and that just might not work all the time. So one of the first problems you're going to run into is that the stair stringers aren't always going to fit. Like I said, you're going to put the stair stringer in and you're going to end up with a small riser at the top. And you might not be able to see it very good, but once we put the tread on, you can see what I'm talking about. We got about a 1-inch riser, and this stringer has a 7-inch rise on it, 7-inch risers on it. Same thing would hold true if the landing or platform you're trying to build the stairs to is a little too high. You're going to end up with a tall riser, and this won't work either. So now here's what usually ends up happening. Someone will go in, and I went ahead and made this a little drastic here, but this isn't uncommon. You could be 2 inches off on your stair stringer, or on your for what you need. You go purchase a prefabricated stair stringer, and this is what it looks like. And I think in here we're a lot farther off than 2 inches, probably more like 6 inches or 5.5 inches. But it's not uncommon to see this. Someone purchases a stair stringer, and they might cut the bottom off of this, you know, and they might cut the edge off of this and slide it in, and they might actually do some cutting on this. I've seen that happen before too. And like I said, the best way is going to be to cut your own stair stringer. Landing too high, this is what they do. Of course, this makes sense. And like I said, it's not uncommon to have someone get a prefabricated stair stringer, make a cut here and a cut here, in which of course you would see that you've now, if I cut this across here, I've now lowered this particular riser height. And cutting this right here, I wouldn't have affected this, but the treads, and I've seen them go in and take notches out of this.
and get a level out, and then you have risers that are inconsistent. You know, you might have a 6-inch riser here, a 7-inch riser here, a 6 3/4-inch riser here, and so on. Now, one of the biggest problems with cutting like that is that you might actually need to cut in order to get this. You might cut into the area here if it's a 2x12 and you have 4 inches of meat here, let's say, and once you cut into it and get everything where you want it, you might only have 3 inches. So that's not going to be a good thing either. Something else you need to know about prefabricated stringers: they will not be cut at the bottom. If there is a 7-inch rise, the bottom is probably going to be 7 inches. And if you have a 10-inch tread, the top part will be 10 inches. If you're going to put a ledger in here, it's going to require you to modify the stringer. And of course, the tread thickness here will need to be subtracted from the bottom. So not uncommon to end up with this. I've seen this plenty of times. You go ahead and you just put the prefabricated stair stringer on the ground, put your tread on top, and you end up with a taller riser. We have a 7-inch rise, like I said. And then at the top, you would end up with a 5.5-inch riser. Not uncommon. What you would need to do would be to cut some off of the bottom. The tread thickness is, let's just say you have an 1.5 inch tread thickness. You are using a 2x12 for your tread. That's an 1.5 inch thick. You need to cut 1.5 inches off the bottom. And you can see here, by cutting 1.5 inches off the bottom, you lower the stair stringer. This provides us with the correct riser height at the top. So lower, cut some off the bottom of the stair stringer, and then that will bring everything into correct order here. And like I said, if you need to, if you're going to put a ledger on here, a ledger would be something like a 2x10 that would nail to the platform. Same run parallel to the rim joist here. Then you would need to cut some off of the stringers here. You know, again, like I said, not uncommon to see somebody nail a ledger on here, nail the prefabricated stair stringers in, and then end up with if you have a 10-inch tread down here, you're going to have an 11.5-inch tread here. Not uncommon for that. So if you do actually purchase a prefabricated stair stringer and it's close, within an inch, something like that, and you think you can get it to work, just don't forget that the bottom will need to be modified, and the top here might need to be modified also, depending upon how it connects to the landing or platform. And if you're going to be attaching a wood stringer to concrete, make sure that you put some type of treated lumber on the bottom of it, which would require you to cut maybe another 1.5 inches off of it. Again, more of that in my stair building books. Don't forget to visit the website. Here's something I saw the other day and thought it would make a good video if you are building bracket stairways. Using brackets like these to attach to a wood stringer with wood treads, make sure that they are positioned to where they are less than 1 inch away from the front. I like to have mine 3/4 of an inch, something like that. And do you need to go all the way to the front? Well, I'll leave that up to you. The reason why this is because if you're using certain types of lumber, the corner can actually break off of the tread. If you have a split that runs down the center of the tread or the edge of the tread, you can actually break the front off, and that could cause an accident. And it happens more with 2x material, stuff that's 1.5 inches thick, maybe 2 inches thick, and it's not a good thing when it happens. Why? Because you can actually fall off of the stairway. So let's not do that. Make sure that you move the brackets to the front. and not to the back. And I know this this is a little ridiculous. Who's going to put a bracket back here? I've seen this done before. I'm not kidding you. I've seen this done, and it doesn't work out too well. And it's if you need more help, get the book. I'm going to put a tab, a link right here, I believe, where you can get the book if you're looking for more information on building bracket stairways actually that are going to be safe and not like this. So 1.5 inch material to 2 inches might break at the if you get a crack down the center. I've seen them wear away as people walk up and down them. Keep in mind that you are putting more pressure in the front than you are in the back. If I was going to walk up this stairway, I'm not going to step in the back. I'm going to step more towards the front, and that's where your support needs to be for your treads. For all of you who watch my videos regularly, I get a little lengthy on them. I'm going to try and make this one less than 2 minutes, so let's get started. Someone asked me the other day what it would look like, how you would actually frame a window, corner window, without a post for the support. And so here we have regular standard construction with mitered corners. If we remove the post, we'd probably have some problems. But there's your solution right there. Looks a little bulky, but this is normally how it's done. You will put a beam in there. And again, I'd imagine you could do this in the floor too, but you would put a beam in for your window header. And I just made this one go all the way to the top. You might not need like a 4x12 or something like that, or a 6x19, you know, a 4x10 might do. And you simply cantilever it like you would any other cantilever. 1/3 of the span can extend out 2/3 back. If this is a 3-foot window opening, 3 foot, this needs to go back at least 6 feet to give you an idea. So this is basically all there is to this. Don't need to do a lot of narration. Picture is worth at least 1,000 words here. Your trimmer, framing studs, your other header. It's going to have a hanger here. And some people say, hey, could you miter the corner here? I have not seen, if I run into a situation like this where it's supporting a load, it's always got the hanger on it. Maybe the miter is taking away from some of the structural support. So this is almost, this is pretty common for this type of construction. And you can use a regular hanger. I've done it before myself, but they do sell a special hanger. We used to call these inverted hangers. I don't know if they still do. Install an inverted hanger and then put the header in there and connect it to the other header. Bottom sill plates can be mitered, or you can run this through. You could make a double plate here, like you would a corner on any other house. You know, run one plate to here and then have the other plate go past it, and then run this one past, and then run this one to here. Hope that makes sense. But anyway, that is it. This is how you make a postless corner window. And it is off to the next video.